Hello and warm welcome to Func Prog Sweden, everyone. The final Func Prog Sweden of the year. And for those who are new to Func Prog Sweden, this is the meetup where we talk about functional programming. Anything in functional programming, anything that... Are we good? Yep. Anything that's functional programming, like functional programming languages, but also functional programming concepts. So warm welcome to all new viewers and to all recurring viewers and all recurring members. Welcome back to Func Prog Sweden. Yes, so let's hit the agenda. First up, we'll do an intro by me, Magnus, and then we'll do Excel, the world's most successful functional programming platform by Houston, Haynes. And then we head over to Tomas and his presentation, Elm Beyond the Browser, type-safe scripting with elm-pages by Tomas. Yeah. And then in the end, if you want to head over to Discord server, and if you have more elaborate questions, please head over to the Discord server and just join the chat if you have more questions. First, we would like to thank Autobeat. Autobeat is IT Consulting, a company which is based in Stockholm and in Ho Chi Minh City in Vietnam. They are working extensively with functional programming, and if you want to know more about them, please head over to their webpage or into social media. Yeah. And then growing the FP community. So 6 years ago, we were first time we ever sent live from this studio. So first there was Func Prog Sweden, which wasn't the plan, but it became an online meetup because of or due to COVID. So we, after like December 2020, we have sent more or less one meetup live per month since then, actually. Then as things grow on and we want to grow and spread the functional programming and grow the community, we added in the spring of this year, 2025, we added the Func Prog podcast and welcomed Christopher Ekeroth. He's the host of the Func Prog podcast. And then in the autumn now this year, in October, we arranged for the first time a Func Prog conference also here in Stockholm. It was only a half-day conference, 4 hours, like in the afternoon. It was very successful. We didn't know, once we run it, we decided to let's do it again. So next year we'll come back with another conference, which will be much longer. And then with start from next year, we will run more meetups under Func Prog Conf or under the Func Prog meetup, which will be run in Stockholm. So next year we'll run a lot more meetups. Not all the meetups will be live streamed. Some of the meetups will only be like in-person meetups, and we will also run the conference. So now if we head over to the schedule, we can see here like 14th of January, we'll run a meetup, a Scala winter meetup here in Stockholm at Spotify. Then on 20th of January, we'll do an online meetup again, when we already have some presenters available that will come on and do good presentations. And then 17th of February, we'll do another online meetup. And then at some point in March, we haven't finalized the date yet, we'll be back in Kivra and run a meetup. And then in October, we'll come back again with the Func Prog Conf, but this time around it will be bigger, it will be more presentations, and hopefully also more attendees coming and joining and having a fun time. So, if you want to support Func Prog Sweden, head over to the meetup or to YouTube. Make sure to subscribe and become a member in the meetup and subscribe on the YouTube channel. You can also head on over to the meetup group or to YouTube, and you'll find the invitation to the Discord server that we run. If you have any questions during the presentation, please use the online chat in YouTube, or if the questions are too long for the chat in YouTube, head over to Discord and ask them there. With that, let's get started, and warm welcome Houston to Func Prog.
Hi, everyone.
Sweden. Hello. Hello and warm welcome.
Hello from North Carolina, the U.S.
Yeah, warm welcome, Houston, and the stage is yours.
Well, thank you so much. So today I'm going to talk a little bit about what I guess you could say, is my own personal journey, but also I think it is a larger, both technical and business case for helping to reconsider the role of functional programming and how it is already in wider use than anyone is thinking if they're only thinking about being inside the software development bubble. So I'm going to go ahead and ask to start with the slide deck, and I'll go ahead and jump into this. There's only a few AI generated images, and I asked it to do this, and I thought it was really cute. So this is my cover shot. And there's a few others that are a lot of fun. But the theme for this is that the spreadsheet, and started with Excel, of course. The idea is that Excel is the 800-pound gorilla in the room, as it were. But there are open source spreadsheets, as well as those provided by other hyperscalers that now are taking a significant share of that. So I just use spreadsheets as a term. But you'll see Excel show up as a term. Most people have that reflex of recoiling when they see a Microsoft thing. Oh, that's not open source. I don't, the idea is that there's a wide pastiche now, and the spreadsheet norm has all kind of flowed from that. So I'll be referring to spreadsheet and Excel more or less interchangeably, and that's not an accident. So this was a surprise to me where the, okay, so somehow my image is missing from that. That's interesting. So in there should be an image of me from 1995 where I'm with Bob Moog standing over the top of a modular synthesizer. My background's in audio and electronics. I also have a minor in computer science from college. And I was always fascinated by the composable nature of the modular synthesizers, and that was kind of my little wink and nod to the fact that I was kind of attracted architecturally to functional programming by this early sympathy that I had from the hardware and analog days. I'm also doing some functional programming all the way down into microcontrollers, which is a reason why that image is there. So back in the late 80s and early 90s, I studied under Bob Moog here at the University of North Carolina at Asheville, and then helped him start his business that eventually became Moog Music, which is now resurgent as an international brand. I've worked in hardware and software projects for 30 years, and before we got started, we got a chance to touch on some of that. None of that's important for this particular talk. And also tangentially, I've been involved with the F# community long enough that I eventually took a role for a time as a member of their the board of trustees for the F# Software Foundation, which is a nonprofit that manages the IP around the F# language itself. So one of the things I wanted to talk about was the need to kind of correct the perspective a little bit whenever we talk about functional programming. And this was a surprise to me. We'll get into that in later slides, but I want to start with kind of like the basic reflex that I think a lot of developers have, which is also the same reflex that I had for many, many years, which is as soon as someone says, I mainly work in Excel, you start to eye roll because you think of all the problems that they might have invited for themselves. Think about the difficulty of translating all of the formulas into actual code. And this was back before I was doing a lot of functional programming. So, and particularly if you're working in the data sphere, you encounter this really consistently. And of course, people end up actually developing a level of craft. And later we'll see in some of the slides that can end up coming back to Python. And that's part of like the I guess you could say a negative anticipation of that eventually becoming a reality that you have to deal with. So you'll see this, this conversation where you're trying to smile and kind of look at what they're doing, but at the same time inside your head, you're like, as soon as Excel does what Excel does, which is turning a decimal into a date or a number into something else, it's all going to go sideways and it's going to be falling like a house of cards. And that's a natural, everyone's had to deal with that. It's a natural reaction. And the legitimate issues are those issues that we always list. And these are issues that I've always listed. And that's, of course, the limit for the number of rows per tab, the inability, when they have 16 spreadsheets that are all different versions that they themselves can't keep up with the version that they should be showing you, which is the latest or what have you. The lack of an actual, I guess you could say, objective audit trail. They kind of have they can build their own audit trail if they're very deep Excel users. Of course, the fragile data pipeline or really not having one. And security and access control, where once you email that Excel spreadsheet, it's out into the wild and anybody can do anything with it. And of course, that's changed a little bit over the years, but the idea is like, these are all the general things that happen with an unmanaged artifact like that. And then, of course, the thing I mentioned where my numbers are all dates now. If they ended up doing something untoward and they kind of get off the beam, as it were, and Excel can kind of not do a very good job of helping someone back on. So when you give all these reasons to somebody when they say, I use Excel, and say, this is the reason why you shouldn't be doing it, that's when things kind of get quiet and they kind of pull back. And this is a natural reaction. What they want to do is they want to hear somebody express a reflection of their needs, and really what they're hearing is all the things that they're doing wrong. Now, I do that. I did that. And I've gone through some training with a methodology called nonviolent communication. And I've really tried to pivot away from being in that tech nerd perspective and just reflecting my expertise back at them instead of actually hearing the message that they're actually sending. So different people are in different parts of that journey. And I think if you've been involved as a consultant or if you've been a software engineer for a long time, over the time, you eventually develop some of those reflexes to counter that immediate nerd reflex that you have of telling them all the things that are wrong with what they're doing. But the problem is that this can end up creating a perverse cycle that works against you, and that you either don't get the project or you don't get the participation that you want, and the project doesn't have the traction that it wants or that you want for it, and that shadow IT develops out of that. And then, of course, all the other secondary issues around office politics that we all know about. So the problem is in ourselves. And basically what, the idea is to kind of have a little bit of reflection of saying, how do you view what they are doing in Excel as essentially good and essentially useful to them for their business purposes, and really take it from that perspective. Sometimes you put on a pretty face for that, but there's actually a really nice way to frame this for yourself and for ourselves as functional programmers. They can also change the discussion that we often have in why functional programming is not more of the norm. This gets a little bit into a video that was put on by, I've forgotten his name, but the developer of Rock, who did this thing at a closure convention of talking about why isn't functional programming the norm. And I remember sitting there the whole time and both enjoying the video, and he did a very good job of presenting it just on the technical terms. And that how functional programming is really proliferated into other general purpose and multi-purpose languages and ecosystems. But the other thing is this Simon Peyton-Jones thing that I will reveal later, is that it already has one. It's just that we don't recognize it because we're so inside of our own mentality of facing inward towards programming languages and not thinking about using technology to solve a problem as a general rule. So we have all these charts that we look at and react to that show this really busy thing. Actually, maybe if I go back here, the bizarre thing to me was looking at this TIOB. This is from November of 2025, and Visual Basic is in the middle of this. And it was a weird thing because Visual Basic isn't really actively developed by Microsoft anymore. It's kind of just in maintenance mode. And the reason why is the methodology, the way TIOB looks at this, and the fact that there's a lot of remediation that's going in, and therefore it's popping up in the chart because there's a lot of people either working to modernize what they've got or to get out of it completely and take it into any of several directions like C# and maybe even F# in certain cases. RedMonk tries to do a different methodology. And again, this is that signal that, if you're looking at query volumes and you're only looking at it for languages, there's two things that you're missing. And this actually started with a project that I was doing for myself when I heard the Simon Peyton-Jones thing and kind of sidetracked, which is just because you're using a language doesn't mean you're not doing functional. There could be functional ways to use C and C++. There are functions because it's a multi-paradigm language. C# is now aspiring to be more functional because it's borrowing things out of F#. And of course, you have all the things in the Java ecosystem where you have those languages that are primarily functional, such as Scala. And I was a big fan of Groovy, really enjoyed working with that for several years. And and there are functional ways to do things with dynamically typed languages like R and Julia and so forth. So when you just see a language, you don't necessarily know how it's actually being used, but you can, of course, make a safe assumption. I call this a PIPL index, but they are really doing this thing of looking at leading indicators and looking at indicators of what people are trying to learn. So at least it's not a reactive indicator of looking historically of what has been going on over a certain period, within Stack Overflow like they do for RedMonk. But again, it's the same players that are showing up. And we'll see and later when you use that same criteria, but then look at other things, you'll see that the chart will change significantly in most cases. So there are some hidden assumptions here. and that these metrics measure a specific population. And I talk about that being inside the beltway of the software engineering community. And the number seems pretty big on its face. So we have 25 to 30 million software engineers in general, maybe more now because of the AI boom, that represent billions of dollars worth of value that's being generated for all the software engineering that's being done. And so all that seems very big. But the question is that the right denominator? And the question is, if you ask yourself the question of, instead of what do software programmers use, and making it software programming and software engineering centric, think about what do professionals do to get their work done with technology, of course, is the implication. Because I guess if you're splitting wood, it's not that much different. But the idea is, if you look at spreadsheets and the way that is used as a technology from a general perspective, you're being much more forgiving than you are within this a very specific inside the bubble view of software engineering. Is now you're in the scale of billions of people that are doing things, and they're not all doing software programming inside of Excel. But the general idea is that the scale is so much larger, you can't. It's very difficult to be able to even use the same arguments. So, it comes back to this thing, and of course there's references for whenever there's a statistic there, but it's not referenced. I'm actually going to produce a document that shows where these things come from, because you don't know whether or not it's a hallucinated thing, or the old joke of there's lies and then there's damn lies and then there's statistics. So methodology matters in the same way that we look at RedMonk different than we look at Pipple versus Tyobe. It also matters for referencing these things that come up that might come from Gardner, and they might just be making it up. So, but the idea is that in general, in terms of just pure scale, you've got 50 to 70 Excel users for every software engineer on the planet. And that's just a reframing to say, wow, this really is a bigger world than we're really thinking about. So the term that we used on the West Coast, and both in fintech and in entertainment, is that what we said was Excel is finance OS. It's a very short phrase. And of course, spreadsheets are the operating systems of businesses, a much more generic way of framing that. The basic idea is that these business leaders who rely on this, or the people that they rely on to build this for them, whether they're actuaries or accountants or people that are just in technical roles that actually build Excel spreadsheets, is they then take the Excel spreadsheet and they work with it and they get to know it and they become familiar with the process and going through step by step. They can do decomposition inside of Excel that they can't do if someone just gives them a React app necessarily, although I'll be showing an app in a minute that's using Solid.js that kind of does the full unpacking, which will be fun. So, there's that cycle that they are always reticent to get engaged in, which is talking to a technology group or an IT group. And then there's this black box period where this group runs off and does a thing. They come back with a thing that then is supposed to represent what they are doing in Excel. And there's what to them looks like no coupling to it whatsoever. And that happens all the time, particularly in data projects or analytics projects. And the basic idea is they have that gap where now they have to go and throw away the investment that they've made in Excel to reinvest in this process that may not look anything like Excel. And sometimes that means that they get there and you end up having some success, but it is a second journey. There's a technical journey of that gap, of them, that black box period where someone has to go off and do the work. And then there's that second reacquainting thing after they've already put a significant investment into getting familiar with their decomposition of the way they see things within Excel. That's neither good nor bad. That's just a reality. So, and from their perspective, Excel and even throwing around CSV spreadsheets and then an email of like how things are calculated, that feels lock-in free. And to a certain degree, it's bizarre, but also kind of is lock-in free. You're not married to a specific language and therefore, eliminating constituencies from being able to have the conversation. The Excel spreadsheet model, or whether you're using numbers or LibreOffice Calc or the Google equivalent, it's all the same visual language. And of course, humans are much more attuned to a visual language because we drew paintings before we actually had written language and so forth. So there is this bridge, though, where the things that they look for that are the positive things in Excel spreadsheets actually do map well to functional programming tenets. And that is not an accident. We'll get there in a moment. Predictable results also kind of maps into that thing of the same inputs, same outputs, referential transparency, the traceable logic and explicit dependencies, which we're going to show later. And then, of course, the phrase of reliable updates is relative to this thing of like they take an action and then they actually see the result of that action, and that helps them gain confidence in what they're doing actually has meaning to them. So they're able to do this cumulative composable building of volume of meaning by having individual places where small things happen, and they make a change that basically builds a dependency graph that they're carrying in their head intuitively. But the mechanics of the spreadsheet itself is actually reinforcing that and providing them an avenue to have greater confidence in what's going on in that view. And as developers, we know that only can go so far, but that it is a legitimate thing. So from our perspective as developers, we can then now have this bridge to talk to them and saying, oh yes, this thing where this cell has this reliable behavior, that's what we call functional purity. And the referential transparency, declarative semantics, and almost like SQL kind of language where they're using a formula that says, I want to express this thing and I want to get a standard deviation of this range of values. And you do STD, STV, or whatever that abbreviation is. They know declaratively what that does, and they select the range for it, and they get a value back. And maybe they did their course in college, but they don't ever have to sit down and hammer out the math by hand anymore. They can just declaratively do it within Excel. And of course, functional programming has that model, and we all know that. And it's one of those magic superpowers that once you get the primitives right, then you can actually end up building something that looks like a higher level DSL that can look like pseudocode, but it actually is executing logic. So these are all things that are the positives of how a spreadsheet can map into the world of functional programming, and gives you an avenue to have a meaningful discussion with them. But there is a dark side, and we all know about that dark side. And that's usually where our first reflection comes from. When someone says we primarily do our work in Excel, you think about all the pratfalls that can happen. And there are real world consequences to this. So I'm giving you some ammunition to make the positive argument. I'm also giving you the ammunition to make the argument of why the dangers lurk, and that there are serious pitfalls that are there in Excel that have actually happened to business, that if you either have selection or survivor bias, you don't think about it as often. You can bring these up in conversations as well. So there's the Fidelity Magellan incident, which was a huge, huge issue back in the 90s. And that was back when $2.6 billion was a big deal and people were all talking about it. And it literally was just a change in a minus sign. So it was, to a certain degree, that this thing of having the control and composability and cell level reactivity is a way to not have hidden state. Because the formula was behind the scenes, it was a form of hidden state and no one saw the mistake and it wasn't caught. So there's a double-edged sword to this thing of having no hidden state within an Excel spreadsheet. The London whale issue, and this is 2012, and kind of in that echo of the big crunch that happened in 2008. And I was working in fintech at the time, that there was this thing that we all knew about inside the Beltway, this huge loss that happened because of a value at risk calculation that went sideways. And it was a transaction that couldn't be unwound, and therefore they had to eat that loss. This was a bit of a kind of, again, it's still in that world of trying to survive that 2008 to 2010 big credit freeze. But there was a mistake that was made inside of Excel where someone hid something, but because it was hidden, it looked like it wasn't actually there. And so whenever the artifact was sent over to someone, and that is that thing about when the email goes out and the artifact goes out, you no longer have control of it. Once you unhide those rows, those things are there, and that led to them being contractually obligated to actually complete the transaction with those rows included in the artifact. So I'm going to circle back to emphasize the bright side, that finance professionals and people that work with Excel in general, even if they're not in finance, backed into and continually back into the advantages of functional programming, even if they don't recognize it. So they didn't read any of the papers. They just needed to get their job done and use this as an experimental tool to build up the knowledge and go, minute by minute and cell by cell and build up into a larger cascade, a graph compute that made sense to them for the larger picture that they're painting. So inside of that inner loop of someone working within the Excel by themselves. There's that positive thing of a predictability, a traceability, and that composition of elements to lead to the bigger picture forming. So whether or not they recognized it, that led them into a functional paradigm. And that's something that functional programmers, when you're trying to convince a technical group or a business group to, take a chance on or to adopt these principles intentionally by activating a group to be able to build an application using functional programming, that you can describe the positives of that to them in terms that are very grounded and very real to them. So there's more than just a surface level and visual level of connection in the way that functional programming is involved with spreadsheet architecture. You can see here, of course, we're talking about all the theory and all of the elements that in our world that we really hold dear, that actually maps over into Excel. But that was actually intentionally done by Simon Peyton Jones starting back in 2017. So Excel has already existed since the 90s. Excel, it seems like it is a Microsoft native project, but it's not. It actually started on its own, and it was in the world with Lotus 1, 2, 3, was eventually acquired by Microsoft, and then now has become an institutional centerpiece for the Office suite. So over the years, that's continued to develop, and they wanted to go to the web, and of course, with Office 365, we know where that has all gone. But Simon Peyton Jones was curious. He was in Microsoft research and was interested in actually figuring out a way to do a formal expression of the full calculation engine for Excel, which is written in C, and took no Microsoft dependencies because it was built outside of the Microsoft ecosystem, and re-expressing it within TypeScript because that was being developed at the time, in order to be able to support what eventually became, I guess you'd say, Office for the web, or I forgot what they were calling it back then, And he actually built this calculation engine and expressed it in F# before he then wrote it in TypeScript for calc.ts, and that eventually becomes a link that I provide here at the bottom, and will be part of the links that you can follow. And there are articles from that period where Microsoft Research talks about it. I think it's from 2019, which is after they'd already done all the hard work. So his goal was not only to recreate the calculation engine for Excel proper to a web available version in TypeScript, but he wanted to also add a Lambda and to make it Turing complete. And so that's where you end up seeing let expressions and Lambda showing up. And that was something that kind of leaked over from F#. And I guess you could say OCaml by extension. And so you end up having this thing where we've all seen this, where you have a sum over a range, and you have all these things that you can express whenever you show that formula to someone. Say, hey, this is just functional programming. These are the things that are happening whenever you see this formula in an Excel spreadsheet. Here are other examples, and of course, Lambda and Reduce is kind of a little bit more late breaking news, and not every calculation engine has this, but in the ones that are more advanced and more complete, you'll see this, and so you can end up having things that actually look like a pseudocoded version of Lambda calculus that ends up actually being that and doing that. And of course, here I talk about the availability of recursion and currying and things that we all talk about and love. But again, you can put it in context of putting it inside of an Excel spreadsheet and say, whenever I say this thing, it's exactly what this spreadsheet is doing. It's just happening in an application. So you have that runway that's available to you to provide things to them that's not just the surface level, but actually the calculation engine underneath is actually doing it the exact way that you do when you do functional programming in a managed application. So what I have here is a couple of screenshots from the application that I built as a sample. And the idea is that the things that look like a web version of Excel really underneath the hood is still just functional programming. This is the reactive cell that, as you see, is described here. It basically goes through and propagates through the graph, and only the affected cells will actually compute. Here's a formula expression that actually it is designed to return another function. So this is like this higher order capability within functional programming that it actually happens in Excel all the time. So again, it's that thing of like giving them an example to say, hey, whenever you see this thing was happening where you're actually taking this function and passing it off to this other thing because you have a reference to it, we're just doing the same thing in here. And anyone that's done advanced formula construction and spreadsheet manipulation within some spreadsheet application, they're going to have some kind of intuitive hook for that so that they can recognize it and see it and build a stronger bridge for them to learn to trust that. So I am going to switch my screen to show my, yeah, thank you. And I'm going to go over here, do this. And now I'm going to go back to hopefully, and is this going to be a problem? Let's get over here and do, can you all see my screen? Hopefully I didn't flash you too bad. I'm actually going to double check. I'm switching between. Can you see what the spreadsheet?
Yes.
Okay. This is blown up as large as I want. This is basically a solid.js application that lives in the browser. It's deployed in Cloudflare and was written in F# and then compiled to JSX through the Fable compiler. So the basic idea is to be able to show, that you have these formulas that pop up, and I apologize for those that have small screens and can't see that, but it will get better here in just a moment. Then when you change these factors that go into the calculation, let's see if I can actually make it a little bit larger. Change these factors in the calculation that it goes through here in the console and actually gives you an output of what was actually done. So it tells you the formula that is being used and considered in the recalculation that's done. So let's do, there we go. That's a little bit more realistic. So this is the kind of thing that you end up seeing inside of Excel all the time. And this is, a garden variety thing. Instead of you having the formula bar at the top, I'm just doing it as a mouse over. So it makes it a little bit of a convenience feature for me. If you don't like the very small type, I apologize for that. Whenever I blew this up to be a little bit larger, the mouse over still doesn't make that type any larger, which is a browser limitation. So, and of course, you can do it for larger calculations as well. This is doing a 30-year amortization and is, if you change this, it goes through and recalculates the entire thing, and you have everything that happens all the way through, and you can just look and see that that's where the calculation is happening. So all this was built in F#. It's all functionally coherent, and then is compiled through solid.js and then eventually to JavaScript that is running in the browser, completely resident there, but still holds all the tenets of, and the Fable compiler circles, there was an early marketing phrase for that compiler that they used that was called JavaScript you could be proud of. Basically, the idea is that F# is actually constraining the way that the unscripted version of JavaScript is constrained to be type safe, and that the type safety and the design time within F# is ensuring that the JavaScript is also type safe in the way it's generated. So, so we have this experience. It's very much a I guess you could say a native web Excel-ish kind of experience. And you also get the benefit of seeing the cascade of how the calculations are being done based on, this is a lot of calculations, so I'm going to go back to this one. That the calculations are showing that how the cascade goes to the dependency graph. And that, for these things where the total return is calculated and the value and the interest earned and everything, that they actually have the right responsibility. And you can see that these cells are not going in the exact same order. This isn't exactly multi-threaded because this is, running in JavaScript, so it's single-threaded, but it does give you that idea of like, oh, there is a place where it's just going to end up doing some kind of, I guess you could say, opportunistic rescheduling of those calculations whenever they come into the queue. And but the dependency order is still being honored for the major arcana of the factors that are in those top cells and then recalculating down through the graph. So this is my example of showing how there is a direct correlation between writing functional programming and getting an Excel spreadsheet outcome. And for folks that are either working in healthcare vertical or finance or any place where people are in the back office are looking to scale up their applications and they principally are working with some kind of spreadsheet model, that having this conversation with them and being able to show them is a way that, as a consultant and a software engineer, that's had a lot of success. And it doesn't necessarily make things happen faster, but it does allow them to have a little bit more of a kind of a trust factor that allows them to understand and grasp what's going on, and therefore give it a little bit more runway. And that over time allows the application to be more successful. So I'm going to switch back to my view of my face here, and then we can go back to the slide deck. Oop, I see Tom. Can we go back to me with the slide deck? Can you all see my face in the slide deck? I'm looking at Tom in my view for some reason. Okay, good. All right. So there is a business case to be made for functional programming, and I'm going to see if I can switch to focus on this. For some reason, I've got what I should have in my main view. I'm seeing Tom in my main view. As great as Tom is, I kind of want to be able to read my slide. I'm not sure why Zoom is doing this. I'm going to see if I can fix it. Give me just a quick second, if you would. There we go. That's a little bit bigger. Okay, so I can read it now. So again, the basic idea is like it's not just a surface level connection. Formulas are functional programs in themselves. So in the part where you can think about Excel sheets or other spreadsheets, in the safe zone of the encapsulation of the cell program, you could say that this is as a direct bridge. You also don't want to leave off the fact that there are other things that happen inside of Excel that you don't want, which is a reason why you want to have a managed application for a lot of these programs at larger scale. So the idea is to change the terminology from using all the things that are phrases that you're comfortable with, which is like we use functional programming, or referential transposition, monadic transposition, and effect management. And that ends up translating to them as saying, that's something I don't understand, and therefore that's a risk. And we don't want that. What you want to say instead is say, we take the exact same things you do with spreadsheets and then reliably scale them and put them in these mission critical systems in a way that you don't have the negative aspects of what can happen within a spreadsheet context. And the good news is that we can use this to, have a bridge that we can use throughout the process. So what they hear are the familiar concepts, the transparency of having that metaphor that they can continually use. And then that then translates into reduced risk. So, this is that, postulating the question, and if this is for that executive that does have an imagination that can imagine this thing of a weird thing happening to a cell in a spreadsheet that they didn't expect or see, even though it's still behind the scenes kind of functionally happening, is because someone made a change that they didn't understand or it can't pierce the veil on. So that's one of those things where they can understand sort of what a side effect means and why weird things happen, and having it under a managed application can actually be all of the positives an Excel spreadsheet offers, but none of the negatives. So this gets a little bit more into the model for that. And I'm at 38, I'm doing well on time. And then of course the novel framing is, you can read the thing. This thing is not really supposed to be a reader deck, but this is a little bit more of a read. But the phrase I always use with them is, we're not trying to take away your favorite calculator. And the idea is like, we're trying to provide the calculator that doesn't break when two people touch it at the same time. And this is a phrase that I use, and I mentioned this before the call, as I was talking about doing work for global royalties group at Universal Music, and all of the actuaries and accountants were all doing the Excel spreadsheet shuffle. We've all seen this, and they're dealing with very large record sets and very large numbers, and there was the constant do-si-do meant that you were really using like SharePoint as a version control, which is a disaster of another kind that we don't need to be talking about right now. So the basic idea was to help them understand the pain that they're feeling, and that you can give them all the benefits without the downsides. So coming back to functional programming for folks with us within inside the beltway within functional programming, and how we can kind of advance this completely aside from deciding that we're against OOP and making an enemy of things we don't need to be making an enemy of, is that there are things that we do get the benefit of that people that using spreadsheets get intuitively from the perspective of them making a change and seeing it happen within the scope of where they're expecting it. And that kind of fearless refactoring that you get within the functional model is the kind of thing that over the life of the application ends up being cheaper to maintain and something that everyone can have a shared vision of. So again, the idea is to give them that comfort that it's not only going to be something that they can understand while this thing is being built in the run up to making it a production application, but also the roadmap ahead is going to be, less bugs and with lower rework and controlled effects, no pun intended, that everyone can understand and manage as they go along, and sharing that context with each other. So in this parallel universe, this is that thing of like in the bigger picture, we're going to say, stop saying we use functional programming and start speaking in terms that they understand. And, applying the same principles in your spreadsheets that are reliable to you and engineer them to build systems that you can trust at scale. And then, of course, there's the selling points that you have of saying that, with Erlang and telephonic systems, and what really made that digital telephony, and then, of course, a mobile endemic, and was really kind of like the first wave before the internet really was a big deal for broadly scaled digital systems, is that they had this unbelievable uptime metric simply because of the functional design and actors. And I'll save that for another presentation. And then, of course, they can go to a more modern metaphor, which is WhatsApp, which everyone should have some appreciation of, that it's still using Erlang, and it's serving 2 billion users, but only has 50 engineers. And that goes to that thing of being maintainable and scalable with a relatively small constituency, and with mental metaphors that everyone can understand, even if they don't trust Facebook, rightfully. So in terms of like who else has been doing this adoption, we have this really nice narrative from Jane Street of using OCaml for 20 some odd years and developing it and helping to develop it in the open. And of course, they do billions of dollars worth of transactions on it. This isn't a popularity story. This is about criticality story. So functional programmers will never win on popularity unless you get people to buy into the Excel story. But the idea of the thing is like, this is not about popularity. This is about the criticality and about the mental model and what matters to the organization. So if the standard charter is a good Haskell story, Bloomberg's use of functional programming. I did a lot of Scala in fintech before I went over into the .NET world. And actually, one of the first things I found in .NET was the ML.NET library. I actually ported the Scala APIs over, which is one of my mental models of like, oh, wait, you can actually kind of do functional programming within C#. It's kind of multi-paradigm, even though it was terrible at it. So again, a digression. And I say here, several large banks have substantial functional programming code bases. That means there's some really big banks that have really big install bases of F# that I don't have their permission to say, so I'm not going to say. But there's a lot of functional programming, and I see the F# world in particular, that's being used at great depth and at great length of time, and for large amounts of mission critical systems that are behind the scenes. And one of the reasons why you don't hear about it as much is because it's a relatively small constituency, and it's kind of their secret sauce, and they don't want to talk about it necessarily. So, the basic idea is whenever the cost of failure is high enough, you have an argument that you can make that they can connect to that doesn't have anything to do about popularity in the broader internet ecosystem. So again, we're going to revisit this thing. This is the Tyobe deck, and then you kind of slide over to, now we're going to use the exact same Tyobe methodology to then go look at Excel, and then add that in and see how it lines up with everything else. And you notice how that squishes just everything down. So this becomes that, because just the scope of the influence of Excel, when you look at it from that perspective, is sizable. Again, with the Redmart metric and methodology, you do the same thing of looking at searches and understanding within Excel, and you end up seeing largely the same effect. Where Excel, or this is actually all spreadsheets. So I broadened it to not just look for Excel, but look for pages and numbers and whatever the other weird names, LibreOffice Calc, which is what I use. And then, of course, Pipple is the same, is not the same, but it is interesting because this is about what they are looking for, what people are learning. And so this is a little bit different, where you can kind of see that, spreadsheets are down the list. And I think I might have labeled it as Excel here, but it still makes the top 10. So there are people that are still working with Excel and figuring out how functions work and, how to use Excel. And that still is above Ruby. That's pretty broadly based, and people are using it pretty significantly. And yet Excel is still in this list, even when you're looking at it strictly from a function development perspective. So there are, when you broaden the perspective and when you actually are clear on what really matters for the things that you're going to end up having a discussion with someone about, that's a decision maker, functional programming folks actually have a really strong argument that's based in the fundamentals. So this is the thesis restated, and the spreadsheet succeeded not in spite of what they are, but because of it. And the idea is that you're not going to be asking the leadership to trust something that's abstract, and it may still be abstract, but it's an abstraction that they recognize. And this is just a quick chronology of, VisiCalc, Lotus 1, 2, 3. I mentioned that kind of in passing before. And this was my own little thing of like, here are these benchmarks. And there's so much that's happened since that time in the world of, I think there's I forgot the open source calc engine that's out there that's in TypeScript. And that was part of what I used to kind of look at for a model for building the calculations that I did in F#. So I spent quite a bit of time looking at an application in my ecosystem that takes TypeScript SDKs and converts it into F#. And so I kind of go back and forth to understand how that works. So the proliferation of those spreadsheet calculation engines are such that it's no longer the lock-in that you get with the Microsoft Excel lock-in, as you have all seen online and everything. So eventually I'm going to be putting up a link that is a web page in my blog that actually has all of the references to all of the different methodologies and everything for, TIOB and everything else, as well as some of the Microsoft research references and a few others. And that will be available on my blog, and I'll be sharing that as soon as it's done. I'll be doing it probably after we're done with this session. And I just wanted to take a moment to thank everyone for listening all the way through this and for writing out this all the way to the point that now I'm ready for questions. So thank you very much.
Thank you very much, Houston. Yeah, thank you very much. Was a really good presentation. I never heard anyone coming up with this. Is like the best twist ever. Have you used this type of? I mean, what I want to say is, like, have you used this type of selling point towards someone, towards some kind of key stakeholders?
Absolutely. This is part of my arc. There's a Channel 9 video that was actually the real inspiration for me, that when I watched it, I was just like, it's like Excel is the best functional programming language. What the hell are they talking about? and then I nerded out, watched it. A lot of it went over my head because, of course, they went to monads, and I wasn't really ready for that at the time. And but then of course, I used LINQ extensively within C#, which is very functional because it was developed by the same group who helped develop Haskell. So they're like, oh yeah, select any as a monad. And I was like, oh, I got it. Thanks. So I hadn't really developed a narrative to get engineering working groups to be able to get analytics people or people that deal with the finance side and with the big data side of their company, because there's that thing of like, there's the operational applications and there's the analytics sphere over here, and they have this little data transform in between it. And of course, I see it as having a confluence between the two all the time, because I'm the person that was usually building the plumbing. And the basic idea is that people were taking this extract out of these operational systems, and they were just, building them into Excel to then go and do transforms. And I'm like, you're basically just building a really poorly defined data warehouse. And they're like, you just said poorly defined. And after that, I stopped listening. So the idea of developing this narrative of getting somebody on board with doing things a certain way, and that's just, it's convincing people to do stuff within Scala or within R, or sometimes within C#. And that was doing Spark transforms. I'm like, this isn't that different than what you're doing within Excel. It's just a lot faster. And they're just kind of like, oh, I like faster. So you give them a little bit of congratulations for this as being close to the model that they're using, and then you get a lot more runway. And I just kind of backed into it. And then learning that Simon Peyton-Jones actually built calc.ts after he did Project Yellow using F#, and I was kind of like, oh, that makes sense. So that was a really good thing. So I backed into this, having this narrative, and taking this to both in healthcare and finance and people, back office and other industry verticals, getting folks to kind of trust that doing something within a functional programming language, and mine of choice is F#, couple this Excel spreadsheet, and it's just a .NET workload, you immediately get a lot more runway and you get a lot more wins that way. And these applications, once you deploy them, they stick around because they just don't need a lot of maintenance.
Cheers, thanks. Next question. I mean, the flex grid you showed, have you used that in any kind of production environment, or has anyone used it, or is it more like to show how it works?
No, I just built that for this, but it was my exercise.
Yep.
I'm building 2 frameworks. Yep. I'm that guy. So I'm building a compiler that takes F# and goes through MLIR and then eventually other lowering strata, primarily right now LLVM, to do native compilation. I'm also doing another Fable compilation that doesn't use React as a front end. And it doesn't use .NET as a backend. So there's this very common stack within the F# community called SafeStack, which is Suave as a .NET backend. It uses Azure as the A, F is F#, and then E is Elmish, which of course we're going to be talking about that in a minute. I'm loving this connection to the Elm presentation that we're going into. And I love Elmish, and I see everything in those terms when I'm building this kind of model. And the idea is I want to do something that doesn't use React. And so this Excel spreadsheet in the web was to do solid.js, which uses the signals pattern. And it is sort of without subscriptions. It's really not a subscription API. There's still subscriptions happening behind the scenes, but that's being handled for you in the graph that's built as the solid.js builder kind of decomposes into the reactive graph that runs inside of JavaScript. So having an F# semantic model that can then compile through Fable to JSX that then can deploy in the front end is going to be the top layer. So I don't use React. And of course, we've just gotten bitten by a React bug with React on the server with Cloudflare. And I don't like React for other reasons because for me, it's not actually reactive, and that's another story. And then have the strata within Cloudflare for Cloudflare workers also built in F# and also built and deployed there, so that if you have all the nice juiciness there. So I've done a little bit of that. And so I'm kind of used it as an excuse to get familiar with solid.js. It's a very long explanation for a very short answer. Yeah.
But it was a nice flex grid, and I think you really showed the what do you call it, like how it fits together. Yeah, and how it's all functional. Yeah. Right,
and I plan on, of course, it's public repo. I'm going to be putting it in the links that's in the page that I'll be publishing. So you'll have a chance to be able to kind of pick it apart and look at it. And there is a parser library called xparsec that actually comes from Haskell that I did not use because it was outside of my innovation budget. I'm using xparsec for other stuff. It's just I couldn't work it around this. But the person who built xparsec, an fparsec in F# comes from parsec from Haskell. So by extrapolation, xparsec is actually going back to a more structured, more functional workflow that ends up using operators that look a lot like the Haskell operators. So it's that weird hybrid of being in the Haskell world, and I'm really interested in that. So I'm going to rebuild the parser for that in xparsec, so that I'm developing my own chops and keep it available publicly within the library, so that folks, and within the modules within the application, so that folks can pull it down, they can compile it, build it, and push it up into Cloudflare if they want and play with it on their own. But it's fully running in Cloudflare as a Cloudflare Pages instance.
Okay, again, thank you very much, Houston, and thanks for your presentation. We'll put all the links and everything in the show notes so people can see them later. I guess your presentation is public also, so we'll put all the links and everyone can, review go through everything.
And I'll publish There's a ton of footnotes, so I'm going to just do one
Good.
link to a blog post that will have all the footnotes in it. So there'll be one link for you to post.
Grazie. Grazie. Thank you very much.
Thank you so much. I really enjoyed it.
Yeah, we too. Thank you. And with that, we will now head over to our next presentation and our next presenter. Welcome, Tomas, and your Elm Beyond the Browser type-safe scripting with elm-pages. Welcome, warm welcome, Tomas.
Hey,
to Func Prog Sweden. Hello.
Hello, hi everyone, and I really love that I picked the title that is really, really hard to pronounce, so you get your tongue twisters from the top. Yeah.
Yeah.
Hello everyone. My name is Tomas Latal, and I'm based in Czech Republic, and I love Elm. And for that, it was really hard for me to say no when Magnus approached me whether I would like to have a talk on some topic of Elm. But I was thinking about like what part of it, because more or less everything has already been said or written, or is not publicable, or is in the doing. And I kind of thought about that one thing that people are not talking much about, or maybe even didn't know about, is that you can write scripts in Elm, the actual Bash-like, Node.js-like scripts. And you can do this with Elm, which I find quite fascinating, and I would like to share this with you. So for that, I prepared a live demo, because nothing beats live demos, right? If you get something wrong, people are okay with it. If you screw something over, they will say, it's like that live demo gods. You can always like blame live demo gods, that's okay. So, and why not to try something new as well? So while preparing this presentation kind of idea, and because I love Terminal, I found that you can do presentations in a Terminal application called PresentTerm. So here we go. I hope, one question, is this readable, or should I make the font bigger? Please tell me somehow. Okay, I can see.
Yeah, we don't see your screen.
Oh, fuck, what?
Oh, yes,
no,
we do.
I can.
Oh, yes.
Yeah.
We do see your screen. We just didn't see.
Okay.
Now we see your screen, and it's totally readable. It's good. Sorry, Tomas.
No worries, no worries. Like, okay, I can see my screen seeing me but next to the screen, so the screen is visible. Love it.
It's visible, and it's good size.
Yeah, and kudos to everyone on the studio to make it like the camera and the stream next to it. Okay, so let's from the start. I kind of call this Elm Beyond the Browser, because again, scripting is something that you don't think as Elm might be good at, and I would like to show you that it actually is, and everything you love about Elm can kind of like, you can use this in your CLI environment and write really nice composable stuff with it. So short introduction about me, Tomas Latal on GitHub as at Cracklin, on Blue Sky at Tomas Latal. I love Elm. I love building web applications with Elm, and I'm building web applications, not with Elm, but in general, since I was like 15-ish. So I did my portion of PHP as well, and that's maybe that's why I love functional programming languages, because, oh boy, what a ride it was. But here we are with the Elm, and for those people who hasn't heard about it, quick recap: Elm is a pure functional language used more or less focusing the web platform, the web development. You can do crazy things with it because it compiles to JavaScript in the end. So I saw people doing like mobile applications with Elm, or some other crazy. The only platform I haven't seen Elm yet is probably like some ESP chips or some stuff like that. But I believe it's doable even there somehow. I haven't tried it yet. So Elm, mostly web development. No runtime exceptions, kind of guaranteed by the compiler, which is the #1 selling point for people coming from JavaScript and seeing undefined is not a function on a daily basis. immutable data structures, that solely this prevents loads of bugs and you don't need to write loads of tests because of that. It's a type-safe language. Well, you are covered by compiler, so the compiler spots the bugs much more in advance than you are. And it's really nice performance. And what we developers like about it is like having really great friendly error messages. So no like number, column, number, type error, blah, 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 cryptic messages that you have to kind of like dig up. And I think you might see those messages in today's kind of like coding session. Let's say each time you will see like a compiler problem or compiler error message, it's on purpose to showcase you how good they are. It's not because I forgot something. Okay, deal. So if you would like to know more about Elm, Google is your friend. There are lots of nice sources in the internet, and suits yourself to find them out. Part of the Elm ecosystem, or like, yeah, the Elm is a language, but with language you can do quite a lot of stuff, but you don't want to reinvent the wheel all the time. So there are several frameworks like Elmland, which is really great for creating single-page applications, and also one really nice that I quite like is elm-pages by Dylan Kearns, and currently they are currently they are in the version 3. And it started as a static site generator for you. Then it kind of picks on the ideas of having the data sources, I believe it was called in version 2. I'm not 100% sure right now. But it was the idea that you kind of make the compiler step itself take care of getting data from different sources, like from your local markdown files, from APIs, and it kind of like complements the gem stack, the JavaScript APIs and markdowns kind of idea of creating web pages. Then everything is compiled, everything like static sites, static HTML files are generated. Everything is SEO optimized. You can tuck into stuff like headers for previews on different social media. Like all the niceness is there. In version 3, Dylan like top his game again with adding a server-side rendering option, and I mean, I love that idea, and I think if you haven't built something with elm-pages, you should. And why I'm talking about elm-pages itself is that in version 3, what Dylan add is an option that is elm-pages run, which effectively gave us some nice scripting. Just to note about how you get these data sources in the V2, in V3, it's called backend tasks. And these backend tasks represents these computations that are being run at the build time or script execution itself that gathers all those data, and you get all the niceness that we like in a functional world, like chaining, pure functions, nice error handling, parallel execution if you like. All of this is done by backend tasks, which are vital part of Elm-pages, but also they run the Elm-pages script, or they make the Elm-pages script run, because you can touch local file system, you can touch APIs, you can process JSONs, you can do everything that Elm is great at, and kind of like tap into it yourself, which is lovely. So that's more or less the end of the presentation part. And now let's dive into the show us how the thing is done part. And I'm not sure, I don't have like any feedback, although I can tap into, okay, video fine. I can tap into the YouTube video and the comments there. So feel free to write stuff there for if you would like, and I might be able to read them. Okay, so things are readable. We have our goal done, well, goal set, not done yet. Oh boy, hopefully. And let's start with simple application. So this is like the regular module in Elm application. It's just this step 1. Again, hope everything is readable. If not, let me know, or someone please let me know.
It's readable.
I love it. Thank you for the audible feedback from the studio. So, surprise, surprise, if you do something like script log, hello, Func Prog, Sweden, and sorry for the casing, 2025. That's the equivalent of echo, but you can see it's underlined by the nice red squiggly line, because this produces the backend task type, and we need the script one, so we need to also say that this is the script without command line options to make it run. Everything seems nice and satisfiable, so let's run elm-pages, run step 01.elm, and what we get after a little bit of recalculations, recomputations, hello Func Prog Sweden 2025. Yay!
Yay!
Yay! Yeah, it's working. Something is working. That's good. So, as you can see, we wrote some Elm code, and we get nice stuff in the console. Okay, let's delete this like basic stuff that is kind of obvious and no one needs to see that, and let's move to step 2. And I created like a different branches for different steps, so in case I will mess up, I have a really nice way back. So for the step 2, let us add some command line options, because everyone loves command line options in parsing them and handling them in their scripts, and it allows us to drive the script through all the hoops that we would like. So here you can see there's like a little bit of a small abstraction. It's called program, and we can config this program with adding the option parsers, which is how we are actually going to get or map the CLI options to our internal data structure, which is this CLI options. And let's say we would like to provide a username. And I haven't said it, but what we are going to build is a small script that will touch on the GitHub API and gets us some information about the user with the given username and their repositories, because I couldn't thought about anything better than this for this short demo. So we would somehow need to provide the username there. And we decided that the username will be passed as a username. So we start with script with CLI options this time. And that's what the program, like this part over here, needs to be defined. And with that, we kind of get the our data structure, which is having username in it. And now we can start whatever we would like. So let's say that we would like to first somehow utilize that username provided and split the greetings with that username in it. Again, let's go from simple to complicated or complex stuff. So we have the username, which might or might not be given. So based on that, we do just like a simple case username on this, and in case we have the username, we can spit out some, let's say, hello, dear Mr. Username. Username. Okay. And welcome to Func Prog, Sweden. Oh, Sweden, damn it. Sweden meetup. Okay, and as you can see, like Elm being Elm, it already like nudges me to, not all, you haven't covered all cases. So what if someone wouldn't provide your name, their name there? So let's then make some general, please provide the user name with username. Okay, username. And here we have another error, which because in here the username is users and this is script log, obviously. And it's not user, it's name. But okay, let me just roll with this so you can actually see nice error in the same way as we will get with Elm application, because this is actually running the Elm compiler under the surface. So you can see that user, like, nice try, but that's not what we would like because it is actually name. So let's run this again. We have our message, please provide a username with username. So let's provide our username. I put mine. Hello, Crocodile, and welcome to Func Prog Sweden meetup. So it works.
Whoa.
What is really nice is that this provides, I think the dash help works there. Yes. So just by defining all the CLI options, the elm-pages program kind of tells you or creates this simple help listing all the options that are there with their values, if it's like a listing of some types or whatever thingies, which is nice and handy. You don't need to deal with the help screen yourself if you don't need to, if you don't want to as well. So far so good. And there are 5 steps. So we are the step 2, moving towards the step 3. And feel free to ask some questions if you have them in some chat, in chat or anywhere during this as well. I might be looking to the YouTube right now, but feel free to shout out if anyone would like to see or ask something in the meantime. All right, so let's throw away all the nice changes we did and move to step 3. Yeah. And actually I have, this is the CLI arguments for step 2. And for step 3, let's get us some user data from GitHub. So we will showcase the HTTP request here, how we can work with environment variables, and they are already already done. I already did like this user modules or data modules that we are going to use. So let's take a look. So there in the data folder, we have maybe from some different application, maybe from our web application that we are working with, and we would like to use decoders that we have there to do some scripting on top of it, whatever, like we can utilize that. So here is a decoder of GitHub API data. There is like a small call to that towards that API, which is like this. And as you can see, I'm using here my GitHub token, because without it, the GitHub API is limited to something like 60 calls per minute. No, sorry, 60 calls per hour without the token. With the token, it's roughly around 5,000, so we can have fun with this one. But we need to somehow provide a token to this function, and also we will probably need to provide this username to get the information about the user. And then what these modules are also doing is they are showcasing this user entity, and they are like printing this down in Markdown, and also in something that can be nice for your CLI or terminal in general. And that's all what these data modules are doing. And we have another one for actually working with repositories. It's more or less the same. So just for you to know what we are having, and let's go and do some fun or some funny parts. So if I run this right now, I should get, damn it, Elm username. Let's say I try to find me, and I will get like, yeah, it works, but we have some to-dos in the code right now, which is right here. So the first thing first, I would like to get some token from my environment, and I don't want to show it to you in the process or to have it saved somewhere in the repository or like all that stuff. So I'm using the environment variables as my tool of choice to have these tokens kind of hidden from anyone and like configurable. And for this, there should be backend task env. Yes, it is. And there are two ways how we can read this. There is env expect, I believe, should be. Okay, let me just. Okay, let's do it this way. I have this alias to env. So we have expect and we have get options. The difference between them is that get gets you the maybe string because the environment variable might be there or might not be there, while expect will fail if the variable is not set and returns like a string, so you don't need to deal with maybes, which is exactly what I want right now. So there's this GitHub token environment variable that I want to get. Now I will get this as a backend task. So I need to deal with this somehow. And then when I have it, I can have the backend task.map. Oh, better. And then that'll be better because this takes the input from the previous part and spits out another backend task, so I can change them in like forever. So let's see, I have a token here, and I'm going to call my function fetch with token. I provide a token and a name here, because we are here with this branch where we already specified the username. And I don't need this part. And let's spit the output to the console. So backend task, and then here we would have some user info, and we can do the user dot to CLI user info. This will be a string, but we need actually script log it out like this. Okay, okay. And if we try to run this right now, yeah, okay. Let's go with Elm-03. Yeah, okay. I get another error, and this one is like it's something that gave me a little bit of a harder time to to grasp, as most of those backend tasks are returning this to like fatal error and recoverable environment error. So you can react, or this allows you to react on the error that you get from calling task that could fail. But the and then function, the others are expecting only the fatal error, so as an error, so it's like everything has been dealt with, let's move on kind of thingy. And for this, there is this helper function, which is backend task allow fatal, which is more or less doing like the mapping of the error, throwing away the local error that you don't care about and only propagating that something has failed. So let's fail gloriously together all the way down. So right now it should probably tell me, like, it should compile and tell me, please provide a username. And if I provide a username, if you have any other username that you would like to see but mine, shout at me. I can try it there, so you know that it's not pre-scripted or pre-recorded. But here you can see like we already like fetched the API and get some answers about myself. So yeah, that's how you kind of like talk to backend and APIs and stuff. If you would like to see how the markdown would look like, we just change one thing and run this again. And now we get the same data, but a different output. Yay, surprise. You wouldn't expect that, right? So. Yeah, let's fail gloriously together. Yeah, love that. Love that notion in the chat. All right. So like we have script, we get something out, we can call the API and print something on the screen. So what's next? And next part is to actually start to talk and read the local files, which is something that with Elm, for like obvious reasons, it runs in your browser, doesn't have much of a notion of what the local file is. You can't do, but here you can. So you can read the files, process them, do some stuff with them, call the API based on those files, which is exactly what we are going to do, by the way. And have much more fun with this. Yeah. Okay. So let's restart everything. Throw away changes. Check out step 4. Yeah, okay. There are some artifacts that doesn't need to be there. Okay, that's one. This doesn't need to be there, and this doesn't need to be there anymore. And that other part is my handout with how I should write some stuff. So, step 4, more or less everything stays the same as before, but on top of that, we are actually going to have another CLI option, which is file. And the idea is that we have some, I don't know, like CSV file, but here we will have just like some simple text file where we get, for each line, we get another, like we get a separate usernames of people that we would like to kind of scrape the informations from GitHub off. And we will provide not the username to this script, but this input file, and it should get us all the information for all the people mentioned there. And also we are adding another call, which is a list of the repositories of that users that we are interested in, and print that out. So we get information about the user and let's say their top 3 repositories from that. So we get like the user info here. This is a helper function that backend tasks kind of can combine two calls together. So you can call for the information of about the user and the repository, and when they came back, you combine them and spit out again backend tasks. So yeah, composability at its best as we like it in the functional programming world. And that's why I like to write even like scripts like that. It's super nice. So we filter out the repositories that are not a fork. Well, we filter out repositories that are forks. So we are left with only the non-fork repositories. And we list like the top 3 of them. I think I have like 3 requested there. Okay. And this is like how we get the information for one user. We kind of like go, so yeah, that's what we have. We have how we get information about one user, and now we need to somehow get ourselves a list of user and call this there somehow. So first, let us get it's like processing thing started, or should we? Nah, we'll write how we are going to read the file first. That's probably better. Okay. Yeah. So to read a file, surprise, surprise, backend task, file. And here there are lots of pre-built functions for working with files, and mainly the files with that are in Markdown and that has some like front matter formatting to them, or they are like JSON files. But for simplicity, we will just use the regular most boring file that we can think of, which is just a bunch of lines and new lines. So we read the file name, and because it's a backend task, we do this backend task dot. Again, we just like do this hello fatal, so we don't care about like what the error is. Just like fall through and fail gloriously again. And after we have that, we can have the backend task, let's say map. So in this moment, we should have the content of the raw file as a string. So what are we going to do? We are going to split that whole string based on the new lines. Yeah, it might be something. And Yeah, we can do that probably. And I don't need to do this here. So with this, we have a backend task that gets as an input a file name and as an output list of strings representing list of usernames. Okay. Now, when we are able to read this, I mean, yeah, let's call it out just for fun. So it was a read input file name, and we are having a backend task with a list of strings. So let's, I don't know, backend task. Let's map it, and this is unscripted territory a little bit for me, so that will be fun. So we have usernames here, and for them we would like to let's say we would like to print them out, just like plainly not doing anything with them. So for list of usernames, we can do list map and script.log just for the readability. Let's say name here, and we will just like spit out the name. And now let the Elm compiler be our guide. Okay, yeah, I might probably like, I can get rid of this. We will just like, and let the compiler be our guide right now. So, I mean, for this, it should fail because there is like, yeah. So right now we have a backend task that has a list of backend tasks inside of it. So we need to somehow like compose them together. And for that, we can do something that's called backend task combine. Yeah, so let's just like get this one, and I hope backend task combine, and this backend task combine takes a list of backend tasks and return a backend tasks, one backend task with a list in it. So that's actually exactly what we would like to have here, hopefully. Okay, not really, because function it expects a list, and we are okay. This should be, and then probably, and or not. And if this wouldn't work, I will get. Yay! Okay, it's not. So, but and then is the first one. Yeah. Okay. I will need this to do a little bit differently. And now we are in this territory where I'm probably going to look at my notes rather than trying to go off script and never do that again. Promise. Okay. Yeah, that was not the plan, but we get the names and the map, and oh, it's interesting. So I think we can try to do some black magic here, which is, and oh no, okay, this won't work. Nah, never mind. Let's go. Let's stick with the plan that we had from the beginning and that I have actually prepared, and that's let's read this file name. Come on. I'll read this file read the environment variable, expect GitHub token, and let's put everything into backend task map 2, which takes 2 backend tasks and like gets their values. So we have the names and token, and let's do something with them. And that something that we have here is that we get the list.map, okay, names, and let's do some nice piping all over the place. So we get the names, we map those names to the function that gets us one user info for one person there, and we need a token and a name there. And so this is this part, and then we are missing one parenthesis here, and for this we can also task combine things together. And with this, there's another error here because we are not returning what we should return. But let's take a look on the compiler. What does it tell us? It's just it was a file name or file. Okay. We don't have a file yet, so it will probably fail anyway. So okay, yeah, cool. Right. We get this fatal error and recoverable again, so we are missing our good old backend task allow fatal, which is nice. You let us know. Thank you, dear compiler. And oh, right. My bad, because this has to go here. Ask. Yeah, because the problem is that like read input file is of a different type of the backend task here, and now the whole thing is failing, and now it will be because we don't return the proper type. Yeah, we get this like backend task with the list of something, and we need to just like get out the backend task with the unit. So here comes the dark magic. Backend task. To get rid of one level of backend tasks is to do it like that. And then what we can do is to kind of get whatever we backend task, and then we can get, we don't care what the output is because the output is just the console logs, and we say this is backend task succeed with unit. Okay, so now we have this, and we might also just create ourselves an input txt file, and let's put some names here. So I will put mine. What else? Yeah, I see Dion is in the chat. Hi, Dion. I can use yours, but I'm not sure whether it is Dion Karen. Well, let's see. Maybe it will push through. And let's put Evan Chapliski there. Come on. Okay. So we have this nice input text here. And inside the terminal now, we can, instead of, okay, let's try it out for username. Just, it should work as before. Yeah, it's fetching something. Awesome. Let me just try to, if I remember correctly, Dylan's username. I do. Okay, love it. So now what we can do is to get the file, which is input.txt, and let the script do the magic. And now you can see there are like a more calls, 3 and 1. This one is for like the empty new line at the end. We can filter that out later. But we get the info about me, about Dylan, and about Evan. Nice. And one bad status 404 not found for the empty string. So that's kind of the step 4 out of 5. We can fix that. We can fix that split here, so we can filter. We can filter out everything that is string is empty, and we say not. So we filter out the empty lines after the split with this. So right now, hopefully, we will get just the 3 outputs. Yes, we did. So that's me. There's Dylan with a nice 784 star. Nice on Elm GraphQL and elm-pages, as you can see here. And there's Evan's one as well. Okay. So we are slowly getting to the end, I promise. And thank you for bearing with me through everything stuff in here. And that's actually to write a file somehow. And in this step, like it's nice to get everything in the console out and read it there. But let's say we would like to somehow scrape those informations from GitHub pages and save them in our local file system, so we can then like, I don't know, use some LLM on them and analyze them with something else, like put them further down in the pipeline. And for this, let me again, for the last time, delete everything and check out the last step. So for this step, the only thing that we are missing right now is writing things to file. And yeah, that's more or less it. Everything else stays the same. It's already implemented here. So we are reading the file, and we would like also to spit the informations out to separate files, let's say based on the user names or logins or whatever they are called. So let's, I have the print user info to file function, which is more or less get one user info and spit it out as a markdown kind of helper. So we have this for user info. And now we get like a string out of it, and let's do some magic. And for writing files, there is a backend task .stream, not Steam, stream. And we can create those streams from multiple sources. It can be like probably it can be even a byte stream. Can it be? Maybe not. Yeah, you can work with the gzip archives if you would like as well, but we will just do the simple from string, as we are getting the print user info for file is actually returning a string. So we create a stream out of it, and we pipe this stream through. We can push this stream through different operations with and like compose them with pipes. And we do the backend task, stream, file write, and some file name. And we will probably, no, let's do it here. So this file name will be user info, user login, and let's call it markdown file. And yeah, I'm missing stream here, don't I? Stream.pipe, and here we just stream. We just run the stream itself, which will effectively create a backend task out of it. So we have a way how we write those informations to our file. And now let's just actually use it. So we added like 2 output modes. One is the default one, which is the CLI. But if we add the command line option -- file and the file, well, only -- file, it will create the files for us instead of printing things out to the console. So for that we can just do write to file and put this info, damn it, info that we have there, and it should be, actually it should be it. So moment of truth, let me clear the screen and let us do the step 5, and let's call it for the file input again. It's just to make sure everything works still. We get our information, we spit them out to the command line, which is nice. But let's say that we would like to have output file. And now, fingers crossed, yes, everything is fetched, but nothing is printed, and that's because we have a lot of markdown files suddenly here. So let's look at, for example, Dylan's, and we have here the markdown file with all the informations that we have got. And this is more or less it. This is what this is like the really brief introduction to what Elm script can look like. One last thing what I really nice that Dylan thought of as well is that you can actually bundle the script and create the JavaScript file out of it. So the script can be written inside Elm or in Elm, but you can actually make a runnable JavaScript module that you can then deploy to your CI or like use on any node environment. So let's try this out. And it should be elm-pages bundle script. Let's put in the file itself, and there should be, yes, now there should be the myscript.mjs. So if I run the myscript.mjs, let's say username Dylan, I get the exact same thing, but now running on Node instead of running with elm-pages script. And yeah, that's all, folks. Thank you for listening to my blabbering on me trying to persuade you to write scripts with front-end language. But as you can see, it's doable and it's quite nice. And given that if you have a code base in Elm and you have all those data modules, and you know how you can talk to your API with them, you can actually like script out some work that you might be tasked with quite easily, and that's I think that's really nice, and that's a quite powerful way to utilize all those things. Thank you for listening. Thank you, Dylan, for chipping into the chat and correcting some stuff there for me. And now, any questions?
Thank you very much, Thomas, for your presentation, first off. Thanks. I think you have one question, if the pages library did not exist, what would be the equivalent? Lambda?
elm-pages uses Lambda below behind the scenes actually. Yeah. Yes, it's mostly because, and correct me if I'm wrong there in chat, Dylan, but I think that Dylan was looking for a way how to make those exchanges of data between the server and the page itself quite efficient. And Lambda has implemented the wire protocol, so everything is like there on a byte, let's say byte level, rather than exchanging the JSONs and stuff. And what elm-pages is doing is that they are like hydrating the page. So you kind of like serve the statically built HTML for the first time. So it's like SEO and search friendly. But once it is there, the hydration, I think, is the thing that kicks in. And it kind of like swaps the page, the only HTML page for the actual Elm page that is being there. So and for like this exchange of data between the server and the page itself, the wire protocol is really efficient. And Elm pages is using Lambda as a compiler as well, I think, underneath. But more or less, yes, if Elm pages wouldn't work, then the full stack way of doing Elm applications these days, Lambda is unbeatable. It's awesome as well. Although it's for a little bit of different purposes. And I highly recommend to check the Elm pages documentation site, and especially for that, the part which talks about what Elm pages is not a good fit for.
Okay. Do you use Elm pages yourself, like in your daily work?
I wouldn't say on a daily work, but for my off-work projects, yes, I use Elm pages, and I use like a few, let's say, I put together like a bunch of templates that uses Elm pages underneath, and it really helps quite a lot with what I'm trying to do. And these days I'm trying to actually not hard code data there in this web applications, but rather use something like I forgot the name. It's like a backend as a service, Strapi. Yeah, I believe it's Strapi. So it's something that I can point my clients toward, like say, hey, here you have your like web interface where you can change stuff in your page. Like, I don't know, like you can change prices, you can change like some wording on references or whatever. And when you like hit save, on behind the scenes, Elm pages are being recompiled and kicks in and gets all the data through the API from that server. So I don't need to write my own backend, but I have this option for users. For anyone interested in this kind of workflow, Jamstack is something that you should look out for.
Yeah.
And it's like JavaScript APIs and Markdown stack kind of based, where it uses front-end libraries, static site rendering, and backend as a services, where you can write Markdown files and gets those information there through APIs.
Thanks. Where should you start if you want to start with Elm pages? Is it go to the Elm documentation and then find it?
Elm-pages.com, I believe, is the page.
Yeah.
Let me... Yeah, come on. It's, Elm pages. And here, really nice starting page for anything you would like to touch on. Yeah.
Cool. Thank you again. Thank you very much, Thomas, and thanks for your presentation. It was really interesting and really nice. You've been on here before and presenting Elm, and now it's like Elm pages and scripting.
Wasn't it Elm UI?
Yeah, maybe Elm
Like
UI.
the declarative part, declarative part. I believe so. Yeah.
Yeah, and you promised like no CSS, and a lot of people were, hooray!
Yeah. Here, I haven't written a line of CSS as well, so it might also be something that people can relate.
Some people might find that very attractive. Okay, thank you very much, and thanks for your presentation, and to everyone that joined us.
Having me.
Yeah, and to everyone that joined us, like either if it was morning or wherever you are, thank you very much for joining us for the live stream, and we'll be back next year. With more presentations and more meetups and more fun and stuff, of course. Yeah, it's like a summary. If you want to present or if you want to sponsor, just feel free to contact me, Magnus. You can connect with me on LinkedIn or just Google my name. You'll find all the contact details at some site somewhere. Yeah, and that's it for tonight. Thank you very much, everyone, and until next time, have a nice time. Cheers and goodbye.